All right, welcome everyone. We're live from Lab 42 and recording this for everyone who's watching later. My name is Sergi Castella. This is Trends in AI, a series that we do monthly to review, what's happening in the world of AI, both from the side of news and also from the side of research, going a little bit more in detail. So that's it. I think we should start with some introductions. We have a couple of guest panelists new guest panelists. Introducing you.
So my name is Marcel Vélez. I'm a PhD candidate here at Lab 42 with ELC. And my subject is like explainable AI and AI in general for music and also for playability of music when trying to learn an instrument.
And we brought him because this month has been quite heavy on the music side, as we'll see in a bit.
And we have a special guest joining us online. Elvis, do you want to introduce yourself and what you're doing?
Hi. My name is Elvis. I'm co-founder of Dear.ai. It's basically an initiative to sort of democratize, AI education and research and like different technologies. So doing a lot of work there right now. Before that, I was at Meta and working heavily with the Papers and Code team, and I'm doing very similar things like tracking progress in ML and trends in AI. So I'm excited about the conversation today.
And feel free to jump in anytime here. It's difficult being a remote panelist, so just make use of your prerogative. I'm Jakub, founder of Zeta Alpha, a longtime veteran in AI, and I've been not sleeping very well last month because not because of worries, but because I was on Twitter all the time watching what's going on, and we hope to share some of that with you.
Yeah, definitely. I did have a sense last week when I was trying to come up with a selection of stuff to highlight this month. It was properly stuff was dropping because new stuff was coming. It was a bit stressful. I say, but let's just jump into it. Yeah.
So let's jump into it. We usually start with the news. So this is not really news, but I think it kind of summarizes the sentiment of the moment. The hottest new programming language is English. What do you think?
I think it's a really interesting take. It's certainly true that what people thought could be done just with natural language, a couple of years ago versus what people think can be done now has certainly shifted, and it feels very, game-changing in many ways. So.
Yeah, I think it made a lot of programming more accessible for different people with no or little programming background in general.
Elvis,
what's your take on this?
I've been doing, for some time now. I've been doing NLP research and doing more investigation around language models. That's kind of the thing that I do research. So it's a very exciting trend, I would say. I'm not sure how long it's going to last. I hope it lasts. It lasts for some time now. I think for me it's exciting because it is really about this new technology that's kind of emerging and this new kind of paradigm. It's you could see it as a paradigm shift in terms of how we interact and interface with these systems, and understanding and making use of these capabilities. While it's not really a programming language per se, I think it's kind of saying that it's kind of democratizing the technology more and making it more accessible to many more folks. And because of this, we have to think more broadly about other topics like policy and how we use and how we build interfaces and so on. So I think it's an exciting time, and it's definitely feeling like a paradigm shift.
And of course, Andrej is wrong, right? Because it's not English; it's Hungarian.
Yeah, all languages.
Or I don't know.
I'm curious what you think. I mean, you've seen a bit of more the evolution of how programming languages kind of rise and fall in popularity as a kind of trend in the times. What do you think about English as a
So I certainly know that we have a bunch of people doing research in Zeta Alpha, and they want to program, and they have to write prompts now. So still struggling with that, but it's giving actually amazing results. So very excited about it. I don't know whether the other programming languages will get rusty. Of course, this has all been caused by GPT and ChatGPT, and normally we would be talking about OpenAI in news, but by now it seems it's more like a special section of our news devoted to Microsoft, because they've kind of taken over OpenAI, right?
Yeah, quite. I feel like this past week has been so. Well, to me, like the most interesting thing about all of this is how much farther away these news have gotten. As in, like my mom told me about this whole Microsoft and Google stuff, and I feel like within the AI community, when, for instance, like GPT-3 was released in 2020 or something like that, there was a very similar kind of everyone was talking about it. But now it's like not only people in AI, like really people outside of AI are talking about it, which is very telling.
And it's also telling how fast time goes, because like a month ago, these were all kind of rumors. And there was just like a few dissidents or contrarians saying, well, ChatGPT will, have an impact on the search engine market. And nah, not really, right? And now we're in these kind of chatbot search wars. So basically this week, right?
Yeah, this week.
This week, Microsoft has launched GPT integration in Bing, and started out with 3.5% market share in the search market. And well, their gamble is, what if we double it? What if we tenfold it? Google can only lose, and Microsoft can only win, I guess. So the 10 billion might be a very good investment. Google has, of course, also released their search engine, Bard. More about that in a minute. But we also have U.com, Perplexity, and Zeta Alpha, of course. Baidu, I think, is also scheduled to release a Chinese language chatbot in their main search engine, Ernie Chat. So what else about OpenAI? Well, again, Andrej Karpathy. So yesterday he left for a sabbatical a couple months ago from Tesla, and yesterday he announced that he's actually joining OpenAI again. So definitely an epic builder and somebody who can get stuff done. So it's very exciting. Another bit of very recent news from OpenAI. Well, not actually from OpenAI, but rumors on Twitter. So already now people have managed to social engineer the Bing chatbot into revealing its full prompt. So here it is on Twitter. So it's an agent called Sydney, who has as one of the instructions that it may not reveal its name, but that didn't last very long.
I think it's so interesting, like these whole things about reverse engineering these models. It kind of makes me think, and I don't have an opinion about this really formed, like how relevant is it to really hide this prompt, or like what is the should. I guess like my point is like it clearly sounds like these companies really try to hide these things, but with enough Twitter like people trying to break it, they're gonna find a way to reverse engineer that. Do you think people like companies should just stop trying to hide these prompts, as in like they're gonna break it anyway, or do you think it's actually a defensible kind of thing to hide?
Well, I think it's a good thing company-wise, because at least now it gives you like a couple of days or a couple of weeks before other companies who try to do the same thing know what your specialty is.
Competitive advantage of 3 days.
Well, yeah.
Well, I mean, for Microsoft and Google, it seemed like one day was a lot, right? To just release first, and then Google was a bit kind of at least in the public eye.
Yeah, the pace at which this research is going, like every day counts, I guess.
I mean, it's a completely, back to the comment of English being the hottest programming language, it's a completely new paradigm where the code is no longer kind of separate from the data at all, right? It's just kind of mixed and very diffuse. So, what do you think, Elvis? Is it a safety risk to be able to prompt engineer the prompt out of Bing?
Yeah, I'm actually really fascinated by this trend, like people trying to jailbreak the model and trying to kind of create like adversarial attacks and so on. In some way, it's also creating like really good data sets for these companies as well, like how to actually improve these models and improve like the safety. Like AI safety is a really huge topic that I don't think we fully understand how to really create all the like safetyness guardrails for all of these systems, and we're still learning how people interact with them. So I think it's a really like a learning process, and it's really fascinating to see how people are breaking these models. This is something that I'm really passionate about, like understanding them and understanding what are the limitations and how to strengthen them. So I think there's also like the research aspect of this, which I'm monitoring closely and documenting as well. So yeah, really exciting space.
We'll talk about watermarking later. There is, of course, a way that you can watermark the prompts, right?
One lastly before we move, I think it's very interesting will be very interesting to see what plays out best in terms of like trying to align these models during the training or with the prompt versus preventing toxic language as a kind of post-processing step. And you can see that in Bing, for instance, they added some kind of like filtering step where some answers, it starts kind of generating text and eventually it realizes that it was tricked into generating some toxic language, and then it kind of like reverts. So I think it's going to be interesting to see how companies go about this whole aspect of toxicity, bias, and from this aspect of like post or pre-processing.
And failures of prompts. Right? That's of course, Google had to respond. I watched the earnings call from Google, and they were like 2 weeks ago or 1.5 weeks ago.
I think 1.5.
And they were still kind of hand waving it, like, we have the best AI in the world, and
we invented Transformers.
We invented Transformers. We invented BERT. Don't worry, it will be all right. Well, apparently. They called Larry Page and Sergey Brin to come fix it. Sergey Brin looks very happy in this photo. I think that was before they called him. But there was a pull request in the code base. There was a lot to do about that. I'm not sure whether he built the BART model, but they did release it. And when was that?
Well, they announced it. They released only privately.
They demoed it, right? They demoed it.
Yeah.
And the demo is now dubbed the most expensive demo failure ever.
Yeah, like I think it was their valuation fell by like $100 billion or something after they failed.
Which is about 10% or even less.
Yeah.
So, okay, but so the problem was that. They had this demo question about the James Webb Telescope. What new discoveries from the James Webb Telescope can I tell my 9-year-old about? And one of them was actually not true. So they didn't check that. And it was very nice because the guy who made the first images of exoplanets 14 years earlier just reacted on Twitter that sorry about that.
And I think it also highlights how important it's going to be how both Microsoft and Google kind of implement these, because one of the big problems that Google, I think in this demo, was not explicitly mentioning the sources, right?
Yeah,
whereas
it doesn't
Bing,
have source references.
Yeah.
So I think that's really important.
Yeah.
Bing does have.
Yeah, exactly. So like it's certainly like from this perspective, like Bing clearly kind of did that a bit better. And it's not so much about the language model per se being better or worse. It's just like how you present it and how users interact.
Yeah, no language model will make zero mistakes. But the trust is really important. And interestingly, you can see that here on the their side. They have inside Google this other chatbot called Sparrow that was made by DeepMind.
Mm-hmm.
So that actually, I don't know if you can see that here, but that actually does have the source references. So, yeah. And I think that kind of points a little bit to a bigger problem that people are, but that's really the course of this 100 billion stock market fall, is that Google is maybe not organized in the most effective way to bring its amazing scientific stuff to the market. And I don't know, does DeepMind have any products?
Not last time I checked, but... but yeah.
This was a statistic that kind of makes that same point. It's actually from Zeta Alpha data. So these are some of the big R&D labs in industry. Stanford is just there for comparison. I don't know if they're counted as industry these days, but obviously Google is kind of dominating the publication counts, but OpenAI with very few people and very few publications.
No, I think it's going to be super interesting to see like if Google really, because I don't know the exact numbers, but it's probably the company that has invested the most, right, in AI research. And like in terms of numbers, it's clear like the amount of researchers they have is insane. Like the amount of high quality papers they put out is insane. But it would be, I don't know, quite an unexplainable.
They have quite a turnaround to make at this moment, at least in the public perception. Bing is already out there. Google Bard announced. Still a bit of a question. What other alternatives are there, right? So we are using the OpenAI model, for example. I mean, what other companies will compete?
I mean, I guess it would be last month we said that unfortunately, from many aspects, OpenAI is still like the highest quality API language model that you can use out there, and there's other contenders, but they're still not up there in quality. I feel like as of today, it's still a similar story, but there's been some developments. For instance, sort of the Lion Open Assistant that's now crowdsourcing.
I have it on the next slide.
Oh, sorry. Spoilers.
There's obviously a bunch of commercial vendors. Interestingly, in Europe, we have Aleph Alpha and Lydon. And Cohere is a strong contender, Anthropic and Character coming up. There's a bunch of open source large language models like Bloom and GPTJ and Neo. And OPT from Meta, but you should realize that these are not instruction tuned, right?
Yeah,
they're
exactly.
just like regular language models. And on the instruction tuned side, there's also quite a lot of development.
So, yeah, exactly. Like we're gonna talk a little bit about that in a bit, but the Flan T5 is probably one of the. I think that the largest checkpoint that's available is 11 billion parameters. And that's like widely recognized as probably one of the best, or probably the best fully open source model that's available that you can like literally just download and run yourself. And then there's this Open Assistant initiative by the people from Lion that are now collecting a lot of crowdsourcing reinforcement learning from human feedback data.
Yeah, there's a very nice video from Yannick.
Exactly. Yannick
Kilker on YouTube.
And it's actually super cool. Like they've collected a lot of like thousands of samples. So I expect that's gonna it would be very interesting to see because.
Do you know which base model they're going to fine tune?
No, actually I don't. I don't know. Do you know Elvis?
No, I don't know. I want to find out myself, but I think it's an interesting project. One thing I was thinking about like the for the Open Assistant and how this compares with other like. Other systems like ChatGPT and that are more like build more clothes behind the scenes and Claude and so on from Anthropic. I think there's like a really interesting aspect of like the crowdsourcing. But I also think that it's really important to think about like the data collection, how this data collection happens. Because I think the goal is to create a system that kind of, it's like more enabling the human preference, like it's representing human preferences. And I wonder what's kind of the result of a system like this if it's done crowdsourced. If the quality will be there to, be like represent diverse views and represent diverse like preferences and so on. So I think that's exciting. I think it's a very unique project from that point of view. But there's a reason why, systems like ChatGPT, they're like more focused on a specific set of people that are kind of labeling the data because they are kind of constraining, what are the behaviors and so on. So, this is done in the open assistant, but I'm very, very curious what are the results and kind of even the limitations on the capabilities as well. So, but yeah, I don't know which base model. I was thinking about that, like what's the best base model?
I think it would be super interesting because so far I feel like people can only speculate about why OpenAI has been so successful at making models that people have not really been able to replicate. It feels like there's a little bit of sprinkle like secret sauce that they have, and it's unclear like to what degree that's the RLHF, that's like their data. And I feel like, like these initiatives are gonna provide more insight on that, right? Like whether they really get to replicate exactly or not really, and.
Yeah, but this figure, and it's taken from a paper by Facebook, by Meta, the Opt-IML, which came out in December. That paper, so it's benchmarking fairly objectively on this big bench data set and on MMLU, which is a language understanding, pretty hard data benchmark. And you see that OpenAI is pretty high up there of the models, except for Flan Palm. But if you're looking for open source at the moment, probably Flan T5 is the most kind of practically useful one. But mind you, that's not fine-tuned on crowdsourced or human-created instructions. It's kind of translating a lot of different existing natural language data sets into instruction material. Another approach, which is not released yet, so that's Claude. From Anthropic. Yeah. So there was this announcement last week that there's a waiting list. So I added myself to the waiting list, but didn't get anything yet. Elvis, do you have access to Claude already?
I don't know if I have access. I actually applied. I need to check my emails. My inbox is pretty full with stuff, but yeah, I think this is an interesting. I saw a few like reports and a few like analysis from folks that had access to it. And kind of like how they're, the approach they're taking, right? Like it's definitely different, and there's a lot of experts, in Anthropic, like doing reinforcement learning and applying reinforcement learning to kind of tune these models, like for like these human preferences. But I like this concept of like focusing on AI safety and kind of developing like the guiding principles of language models. There's so much that's coming out of it, like so much insights. It's definitely, we saw the jailbreaking example previously, right? And I saw a few examples of where, someone was trying to jailbreak this and trying to understand what are like the guiding principles of the language model and trying to kind of trying to go against it and trying to attack that. And we saw a few examples like Microsoft as well. So yeah, interesting stuff. I don't have access to it. I wish I had.
So it's a very different approach, right? It's basically the language model itself is kind of red teaming with itself, and the sort of reinforcement learning examples are generated by critiquing the output of a let's say basic language model. And giving it some constitution, and that's why it's called constitution AI, like like the principles of how not to be harmful.
Yeah.
And it's asked to critique these responses in the light of those principles and rewrite them and therefore generate. So it's kind of a synthetic data, self-tuning type of approach. Well, everybody's very excited when it will come out. There's a rumor that it's better than ChatGPT, and Google invested 300 million, so now they have 3 AI research lab, DeepMind, their own, and Anthropic, kind of at arm's length. I don't know if it will help them ship faster. All right, so let's move on. It's really music month. That's why we also have Marcel in the panel. So many new papers about music generation came out. I believe, like 1 per day, more or less.
Yeah. I don't know.
Yeah, like this month especially has been very crazy. Every day when I opened my mail with more relevant papers, every other day there was a new model which did music generation. It already started like by the end of last year, where people from, I think, Stable Diffusion fine-tuned their model on null spectrograms, and they released like Riffusion, which had nice musical generation, but you could also hear the limitations of it. And then this month exploded with one of the top performing models being MusicLM by Google, and also Noise to Music. But it also shows the scale of like music, because, for example, MusicLM consists of 3 parts. Every one of them are like around 6, 7, 800 million parameters.
Yeah, it's still like a very modularized. It's not so much like language that is very much like a one like architecture that's like end to end. Right, you still need a lot of these tricks, representational learning, and all of that. I think one of the interesting things about this month is that MusicLM is a discrete autoregressive approach, but there's also a lot of them that work with diffusion. So it does feel like there's a little bit of kind of diversity still in the modeling paradigms of music. And I wonder if like where that's gonna go, or like do you have opinions, or like do you think is this space gonna converge somewhere?
Not necessarily. I also think that music allows for different levels of discretization, because one way to look at it is like you have discrete kinds of instruments, or within, for example, a piano, you have like different keys you can play, which are somewhat of a discretization. And as for like diffusion versus autoregressive, well, I think autoregressive might be better at the moment, because I think diffusion is a more complex domain to work in. But as we see this month, it is not impossible.
So is this Noise to Music? Is that one of the first ones that uses diffusion for music?
I think Riffusion was the first one, right? The one in December. Yeah. That was like the one I remember. That was just quote unquote simply just like throwing diffusion at MEL spectrograms, see what happens, and it suddenly works really well.
Yeah, it sounds kind of funky, and if you throw, I think we have a couple of examples later on.
Yeah, I think it's in the next slide. We have a couple of
so let's
examples.
Listen to some of this.
I guess the most interesting thing to me, at least, was not the music generation so much, but the alignment with the text prompt, right? Because I think that's what makes a lot of the, for instance, generative image stuff really useful. Like when you can really align it with very concrete text. It's not like just the image, the image or the audio sounds great. It's just like you can really control it with natural language.
So are we going to start with Riffusion then?
Yeah. So, do you can explain what this is?
Yeah, so this is an example I found when looking online at people talking about Riffusion, and it's when you put Eminem into Riffusion command prompt, and you actually hear something of Eminem in it, even though the words are not very...
So it's a one-word prompt.
Yeah, it's a one-word prompt.
Yeah, just Eminem or Eminem like rap also gives something similar. But the longer you play with it, you also notice that the way it was trained, and even though you give vastly different prompts, there are some elements which are reoccurring, but still amazing feat.
Yeah. And then we have these MusicLM prompts, which are more detailed.
1 month later.
Yeah.
Yeah.
Like so. So this should be not so simple. Actually,
this is the arcade game.
I think it's a different prompt.
I'm now realizing that I think I flipped not these two prompts, but I think that I didn't get the right, so I copy pasted the prompt, and I think I got the wrong one.
I think this was the arcade game, right?
Yeah. No. Can you play the first one?
Yeah, that's gonna be.
No, this is the arcade game.
No.
No. Yeah. Sorry. Yeah. This is a reggae, and that was the.
So, is it instruction tuned? Does it actually follow all the instructions?
I would say, it's cherry-picked examples, right? So.
Yeah, so it's not instruction tuned. It's like one of the three parts it consists of is like the conditioning of music on text prompts called Mulan.
Oh, sorry. Yeah, sorry. Now,
Yeah.
No, so it consists of three parts, and one of it is like how do we teach a model to generate music based on the prompt, which is very nice. And then they have another model which allows it to have like consistency along longer time spans, which is based on a language model. And then they have this upsampling model because music is very high dimensional. They first go to a lower dimension, generate the tokens at a lower dimension, and then upsample it.
Yeah, it's a bit like the resolution, the high resolution upsampling for image generation in some sense.
Exactly.
Yeah, I think that this also highlights how hard it is to evaluate a lot of generative AI, right? Because like these things, these are cherry-picked examples, right? So like it's easy to sound good when you choose what you show. But at the same time, it's like if you were gonna kind of evaluate how good this sounds, it's like quite a hard challenge to solve, right, from a research perspective. Yeah,
so I think they came up with nice solutions. One way they did it was there's a metric called Fréchet audio distance, which measures the plausibility of music, but not necessarily how well it aligns with the text. And then they also used the Mulan cycle something, which, because the model was trained on text together with music, you can also give it just the music and it will give you the corresponding text, if I'm not mistaken. And then you can see how well it aligns with the prompt you gave your model to generate
it. It's a little bit like back translation thing where you kind of do it both ways and see how well it aligns.
Yeah.
And it often sounds very plausible, but that kind of brings us to the next topic. So, obviously, all of these models are trained on somebody's data. Right?
Actually, it's very interesting. In the MusicLM paper, they're a little bit vague about what data they use to train the models.
Google might have access to some
large data set,
some platforms, some music tapes from the original artist, and so it started kind of with the lawsuit against GitHub, right? Like Microsoft, basically. By people who said it infringed on copyright licenses on software.
With the GitHub Copilot and the Codex model.
Exactly. So obviously the legal system moves very slow, so there are no verdicts yet in any of these. Then some artists picked up the axe with Stability AI and Midjourney, like a class action suit, basically saying that their rights and those of others were infringed, and they didn't want that. But now the axe has really come heavily. So Getty Images, obviously a major copyright holder and on a huge high-quality photographic database that they're charging lots of money to creators to reuse those images, they sued Stable Diffusion for 1.8 trillion, 150,000 per image. And the thing is, they have a pretty good case, actually, because here in this example, this is the original image in the Getty database, and in the generated image by Stable Diffusion, actually, there's still a bit of the watermark from their collection.
It is a really good example of one of the papers we highlight on how you can extract images from the training data set, or these models are have a tendency to do that.
Exactly. So there was a paper about that. we'll talk more about it in a second.
But I really don't know how this whole thing is gonna play out. Like it does feel like this usage of data for training a model and then using it is kind of like different to everything that had come before. So how is law gonna adapt to that? I don't know. What do you guys think?
Especially in like music and art and like images, right? And the language is maybe a bit different, but
well, don't quote me on this because I'm not an expert, but
we're stopping the recording now.
I had a talk with someone who, during one of the conferences who knew a bit more about this, and there's this license agreement when you're listening to music on certain services that you're not allowed to have like a copy of the music, or the way you are allowed to use the copy you bought from iTunes, for example, clearly states the intentions you have, and among the intentions is not that you're allowed to use it for training AI.
Yeah.
So I don't think, but MusicLM, they do test for how much of the output they generate is an exact replica of the stuff they put in. And it's very low, but still, I think is one of the reasons why they didn't publish their model yet.
All right, so let's switch to a bit of local news here in the Amsterdam area. So there was a publication in Nature, right, by a couple of people here from ILC. Jelle, congratulations on this wonderful achievement. We have one of the authors in the room. So I guess you guys defined kind of 5 priorities here on the screen that start with hold on to human verification. I think that's a very important principle. And you talk more about open large language models. I think this kind of democratizing the access to these technologies is also super important, especially for science. Elvis, you're also kind of involved in this democratization of AI movement. So can you comment a little bit on what you are doing in that?
Yeah, I think it's really interesting. Like this debate is also related to the previous one as well. I think this conversation about how to use these systems for this like knowledge-intensive tasks, and how it may be used like in academia to do like research, maybe in a classroom as well. So I think it's a very important article from that point of view that that conversation needs to happen, and needs to happen in the public. There's a lot of like different players, like like lecturers and teachers and so on, and students that we need to kind of bring in. And I think I like the principle of doing this in the open, from the point of view that we need all of these perspectives. These are the people that this technology is affecting. I don't think it's a good idea to keep it in the lab and just kind of push out demos and so on. So I think that's an important conversation, and I really appreciate like the authors writing this. And I saw a couple of them on Nature actually. A few of these like focusing on like how language models will affect like research, education, and so on. So and the accountability is another really big, I think, important point as well. But there's a long way to go, right? Like there's lots of limitations from the systems. There's so many things like policies. We're going to discuss like the watermarking in a bit as well. How to ensure that these systems are being used like responsibly and so on. So there's no guidelines, there's no standards for how we're going to use the systems. So I like that that the conversation is happening in the public, and I want to participate in this, and we are having like community discussions about this as well with our initiative. I'm discussing with teachers and students and so on, and even researchers about how what's the best kind of like what's the guidance here, what's the best way to approach research in this space. How do we push out models? How do we train models? How do we compose data sets as well, and so on. So there's a lot of stuff going on.
So one of our predictions from last month was that the first fully ChatGPT authored paper would be accepted in a scientific journal this year. So the bets are still out, right? Nobody has seen it yet. All right, so a bit more local news. Let's run through it quickly, but it's kind of local and global news, like nature. So there's a case in the Supreme Court that is a Gonzalez versus Google, where the Gonzalez party has lost their daughter in the ISIS attacks in Paris and is accusing Google of contributing to the radicalization through their YouTube recommendation algorithms suggesting ISIS recruitment videos. And it's made it all the way up to the Supreme Court, because there's kind of a loophole in protecting search engines, right? So search engines are not responsible for the content that they serve. And actually there was an interesting opinion piece, an amicus brief, as it's called in legal terms, by a bunch of very prominent researchers, arguing that recommendations and search is kind of the same, and that recommendations should also be exempt from editorial supervision, and that therefore Google's not responsible for those things, or Netflix, or whoever. So unfortunately Martin is not here, but I think this is a very controversial position, to say the least. It's a nice piece to read, actually, this amicus brief. So let's dive into papers. So we're collecting a lot of papers. We also integrated with GPT. I will not spend a lot of time on that right now, but basically we have integrated GPT for question answering, and also for private content and for web search. So we were a little bit earlier than Bing and Google, but it's also a little bit easier for us to release. And when the Google demo failed, I quickly checked on my phone what we answer for new discoveries from the James Webb Space Telescope, and we did not make the same mistake. So that's reassuring. All right, so we have a bunch of other use cases that I will not go into too deeply, but supporting extraction and question answering from many different documents, and for making sense of the whole document space. And that's what Sergi uses in some of his analysis, right? So let's dive into that.
Yeah, so if you want to learn more about this, you can go to our blog. I wrote a blog piece with a lot of this stuff. So we don't have that much time to go in depth with on the papers now, but you can just go to our website and read it there more in detail.
Yeah, so this is the landscape of everything that came out in January, right?
Yeah, exactly.
Up till now.
Yeah, exactly. So this like a kind of semantic map, organizing clusters and then labeled automatically and of the space. Yeah.
And the purple one is the music.
Yeah, exactly.
Generation explosion. So you guys already talked about it a little bit.
Yeah. So maybe you can focus a little bit, just in a couple minutes, on what makes MusicLM special compared to the previous works.
What makes it special? The quality of the music is very good. Something you find with Riffusion or other models is they train on MEL spectrograms compared to raw waveforms. What MusicLM does, or if I'm not mistaken, which doesn't leave out the phase information, basically allowing it to sound more natural to people. But some of the other models, they manage to circumvent the...
Yes, maybe for context, one of the things that a lot of these audio models do is to convert audio into MEL spectrograms, which is a transformation that in which you omit the phase information about the waveform, right? And some people think that's not
you can just leave it out.
You can just leave it out and kind of get away with it. And some people think it's you should really model the raw waveform, and MusicLM actually kind of models the raw waveform, not the MEL spectrograms, right?
Yeah, and something they also that's a strong suit of MusicLM is their coherence and consistency across longer durations, because beforehand it was possible to generate a couple of seconds up to 10-30 seconds of audio, but I think MusicLM was one of the few models that could
up
do
to like 10 minutes.
And it something it could. They added some other interesting features, like you could let it do some storytelling, so it would start off in one type of music, and then after 15 seconds continue a different type, and then another different type.
Yeah, so we'll certainly pay a lot of attention in this space in the upcoming months, and I'm also looking forward to see how scaling up like improves in this space, because these models are big but are not humongous, let's say. So like there's still like kind of room for
My favorite is actually, I think it's the sing song where you just sing a lead vocal. Not that I'm able to do that, but I can, maybe in the shower I can try it. But it makes a full score for the music piece in any style that you want, right?
Yeah.
Yeah, and that's also more like appropriate way to use AI, in my opinion. Like, it's cool that you can generate a song with the push of a button, but it's way nicer if you can allow people to express themselves,
to make it a tool for co-creation. Yeah. I think then the legal aspect is also less problematic, right?
Yeah. And the last thing I want to mention, I think I'm really looking forward to a lot of these applications to be able to run in real time for people to not only use as a post-processing thing, because a lot of these things are basically like a post-processing, but something that people can use while playing music, and an AI has companionship, which it's something that people are working on.
A band for lonely people.
Yeah, exactly.
All right. So another topic which has got a lot of attention is watermarking.
Yeah, a lot of people are talking about how it's problematic that students are using this to do their homework. OpenAI kind of hinted
not only students.
Yeah.
We have some professors in the room. I don't know.
So this is a nice paper that kind of explains this from like information theoretic principle, in which you can watermark a text based on kind of having a whitelist and blacklist of tokens that a model can output given a previous sequence of tokens. And they show that it works really well. However, the issue of I guess my point is this just raises the bar of.
I feel like it's like spam filtering 1995 all over again, right? You start with whitelist, blacklist, classifiers, entropy measure.
I feel like no one's gonna come up with a system that can not be fooled. It's just like kind of like making it harder for people to kind of circumvent this, but I still don't know how much of an effect this will have, honestly, because there will always be ways around it.
I don't know if that's a part of this latest effort by OpenAI, but I think a really interesting approach is to kind of slightly throw off the probability distributions for generation all over the spectrum, and just keep that sort of that as a kind of cryptographic addition to the probabilities, and keep it secret, and then you could maybe.
I guess it's also, at least for me, it raises the question of to what degree do people care whether something was written by an AI or not, as long as there's accountability in the
as long as it's clear,
as long as there's someone kind of like saying
well, I think the upcoming European AI Act is actually going to require everybody who's using AI to generate text to
disclose.
Yeah, to disclose that, right? And I think that's not a bad idea. I think. Get caught. All right.
Demonstrate, search, predict. I like this one because it's this framework that kind of like goes into the next level of what retrieval models and language models can do together. And instead of just doing like you have a retrieval model that retrieves relevant documents and then the language model generates something, you can have a more complex interaction between these two systems. I think it's an interesting direction that things will move to. Yeah. It still has a lot of limitations in terms of like the robustness of the steps.
It's basically like chaining together multiple prompts and all that, right?
Exactly, so it's like a framework.
It's like a compiler for complex tasks in terms of prompting. Very interesting. And maybe watermarking and and preventing prompt, revealing the prompt is part of the programming language in the next version. We already talked about Flan, so Flan is highly recommended. Let's keep it at that.
Let's hope that they also release the bigger ones, even bigger than the 11.
We want it. We want it as a service from Google. Are you listening?
Just make it part of their Google Cloud services, so someone uses them.
All right. So shall we move on?
Yeah, sure. Let's.
So this is a little bit different.
Yeah, this one is a really different.
It's also about programming and
paper.
Language
but programming. This is a paper from DeepMind. So I think about a year and a half ago or something, there was a paper called "Thinking Like Transformers," which proposed Rasp, which was this domain-specific programming language that kind of was a good abstraction to describe what kind of computations transformers could do. Like if you kind of think of a transformer as a computer that kind of like gets a sequence of input, a little bit like the kind of punch card type of analogy, how would you describe the element-wise operations, the operations that kind of like select elements and aggregate them in different ways, or I think like full sequence operations are there's like select, aggregate, and maybe I'm missing something. Anyway, the whole point is that DeepMind kind of went a step further and designed a compiler that basically takes this code and compiles it into literal weights of a transformer. And I think that this is not going to have like direct implications in the near term, but it's very interesting from the
like toy problems, more or less.
Yeah. From the perspective of explainability and interpretability, and kind of like having good models to understand what transformers and neural networks can do, I think it's a very interesting direction.
So what's the deal with extracting training data?
I mean, I think it has very interesting implications. Like it might be a very expensive thing.
It might cost you $150,000 per image if it's extracted.
Yeah,
it's a little bit watermarked though, in the wrong way.
So I guess it's just in the same kind of space of problematic things with generative AI is that that they can generate data that was in the training data, and then I guess this is not so much of a problem if all of the data is public, but as we've seen, a lot of these companies are training on data that is, they just don't fully disclose what data they're training in, I guess also in the hopes that there's no way to reverse engineer that. But it turns out that you can actually reverse engineer.
What's the trick? What's the key trick of
they just literally prompt the model with the same prompts that were in the training data set. So in the training data set, you have prompts and images, right? So they just prompt it with the same prompts because they know those prompts.
The textual prompts.
So, So they just generate 100 or so images, and then they try to match the generated images with the ones in the training data set, and that happens pretty often.
Yeah.
So
you cannot get it to enumerate training examples, but if you have a training example, you can verify that it has been used, basically.
Yes, exactly. And it's basically like a brute force type of thing. Like you just kind of choose prompts, and then if you have like a kind of bank of images that you can compare that to, you can just find
I know
samples.
What Getty is doing right now. So. All right.
And the other little thing that I think was very interesting from this paper is they compared this with GANs, for instance, and GANs have a similar problem of generating the same as the images they were in the training set. It happens less often, but the most interesting bit is that they find that there are certain images that have more tendency to be memorized, and those overlap with the ones in diffusion model. So it's probably something that is not related to the modeling paradigm, but something else that makes certain images kind of more have a stronger tendency to be memorized by the model for some reason. But that's, yeah.
All right. Was this a paper that Elvis brought in, or?
No, I think so. But this is basically a paper that looks into making a chain of thought work in the multimodal setting, which people had been a lot of trouble getting to work, because it's something that has been reported is that when you try to do chain of thought reasoning on smaller models, it actually decreases the performance and models hallucinate even more, which is a very interesting effect of as a function of scale. This work proposes to fine-tune separately on rationals and answer to make chain of thought be more robust in models that are, I think, 1 billion parameters. Yeah, and they get pretty good question answering performance on this science QA data set, which is better than what GPT did without having access to the images.
Right. And you like when old things come back, right?
Yeah, when old things come back. Whenever there's a paper that says...
retro fan.
We had a...
we thought GANs were over.
No, my favorite ones are like, we had an LSTM do better than transformers. And I feel like there's always once in a while, one paper that comes out. But I guess in a bit of a similar kind of contrarian take, there's this StyleGAN paper that they basically just... this goes back to the question, like how much of the advancements are just like people are just getting better at optimizing neural networks versus are the ideas in the newer papers actually even better? And I think this kind of highlights that it's a lot about really the optimization and the little tricks and all of that, not so much about diffusion model being intrinsically so much better.
So it's a little bit similar paper like the ConvNet for the 2020s.
Exactly.
Where you just use all the tricks from the transformers.
Exactly. So I feel like it is a really good sanity check to say, well, maybe it's not so much. There's nothing magical about diffusion models. When you design something really well with GANs, you can also get really good results. And they're more efficient. They have some advantages. I don't think diffusion models are going away anytime soon, but still, it's kind of
nice video.
Good.
More video.
This is this work from Meta that was quite made a lot of headlines. They I think a few months ago they were, I believe they were the first ones to do text to video diffusion models. Well, I think that calling it video is a little bit misleading. It's more like a GIF or like very short snippet. Mm-hmm. But they extended that work into 3D by kind of combining it with neural radiance fields. And it just looks pretty cool. I don't know to what degree this is really useful, honestly. But time will tell, I guess. To me, what I would be most kind of excited to see would be longer video generation.
We have songs now. So we have 3-minute, 10-minute songs. So how difficult can it be?
Yeah.
Right?
But something that captures narrative, right? I feel it's like the gap from image to 3-second video doesn't seem that large, but from 3 seconds to something that has a narrative, that seems like a true...
Language models are really good at narratives, so...
Yeah, actually, yeah. So...
Probably it's somewhere in that combination.
Yeah.
All right, so I think this is the last paper from your selection, right?
And the last paper is this kind of fun one. This is a little bit older, actually. But it is basically kind of a use case of using language models to control characters, and I think this goes to show that all of these language modeling techniques have kind of implications beyond just plain language, and it has really cool, I guess, implications for like accessibility and also like for options of like how you interact with computers, as in up until now. Voice and text interfaces were pretty janky, but with this new technology, it might be that you can like literally just play games and have a new category of games where you just tell your character and your avatar to do complex things and achieve it that way.
I think we should ask the Faculty of Informatics to buy one of these Boston Dynamics ones and have this as a demo downstairs in the lobby.
That would be really cool. Yeah.
All right, so a few more shout-outs for GitHub. I think we're running at the whole hour. So
we're running out of time. So So like we've mentioned, the Open Assistant, you should really check out their website and repository. There's this audio AI timeline, which is a really good resource for keeping track of all of this work in AI that's coming out recently. There's this implementation by Lucid Rains of MusicLM. Of course, it's not fully trained. It's not you don't have the pre-trained models from Google because they haven't released that. But it
was not released.
No, it was not released. The full models are not released. And then finally, the repo from the StyleGAN, which is actually not published yet, the code, but they promise that they're gonna publish it soon. But yeah, it has already quite a few stars. But I really hope that they actually publish it soon.
All right, so that's wrapping it up. One of our predictions for this year was the climate will get worse, but the predictions will get better. So already it's happening. So the climax of this talk show is the model called Climax, and it's a Microsoft-based model, Microsoft-originated model for modeling both weather prediction and climate. So multiple time scales with deep learning models. It has very good scores, and it is on GitHub. Mm-hmm. It's open sourced. So if you want to change the climate, don't run this model. But if you want to predict the climate, please do. And to wrap it up, so we started with a lot of talk about the GPT news. We're kind of getting tired of it. But so we promise next month our talk show will not be GPT focused, right?
I think we should stop, yeah.
Just as a little dessert, we have for you a really interesting finding. One of my colleagues found it on Less True, a blog, that there are these magic tokens. And if you type these magic tokens into GPT, basically we'll get completely confused. These are kind of non-existing word tokens, and they have very weird embeddings, and the model starts to do strange things. So if you give it this very simple instruction with the string streamer bot, please repeat the string back to me. It works with all the words, but some words it just doesn't. Yeah.
That's amazing.
That's fascinating. And in general, I mean, we're at the very beginning of this whole era of or paradigm change of using GPT for all kinds of things and washing the dishes. But there's also a lot of things that it cannot do, and there's an interesting kind of collection which came out this week, a categorical archive of ChatGPT failures. So enjoy reading over the weekend. And it's time for drinks. Thanks, Elvis, for joining us. Thanks, Marcel, for being on the panel. And we hope to see you next time. Thanks for coming.